cloud. All right. So we are recording, and it's time to get the class started. Okay, first thing first, does anyone want me to go over the homework assignment that was just due like a few seconds ago? Or was it so easy that you go like, Okay, we'll go ahead and go over the homework assignment. All right. So question number 1. I think the previous one, the one before this, is something that I probably want to go over to. So this is the current one. Oh, this is somebody else's submission. Okay, forget that. Okay, you didn't see it. Let me see. I have to go back to that. Just functions. There we go. All right. All right. So I'm gonna go into preview mode. So I'm gonna work on this the same way that you guys did. All right. So question number 1, given that X is the set that has A, B, and C as elements in it, Y is the set that has 1, 2, and 3 in it, what is the Cartesian product of X and Y? So you just have to type it in, okay? You don't have to use any prompt. You can just start with typing. You don't have to use mathematical notation because just typing normally would be fine. And for those of you who do not like to work on chores like this, you can just write a program to do it too. So, it's not really that difficult to write a program to do it. It's a double loop, right? So B1, B2, B3, and then C1, C2, and then C3. All right. All right. So are there any questions back there? Hello? Okay, because I can hear the conversation, but I cannot hear the words. But that means other students can hear you too. All right, so that's the answer of the first question. Do we have any questions about number 1? Okay, questions. Then we're going to move on to the second one. Referring to the definitions in the previous question, what is the cardinality of the Cartesian product between set X and Y? Well, I mean, if you have watched Sesame Street, you can do this. It's 9, or you can just count, right? All right, so question number 3. So we are increasingly getting into something that's more difficult. So question number 3 says, reference the definition of X and Y in the first question. So everything is based on how X and Y are defined in the first question. Enumerate all sets that can be considered functions using X as a domain and Y as the codomain. You can consider writing your own program to generate this answer. However, using someone else's code or asking AI for an answer is self-defeating. Okay, and I don't stop people from self-defeating. For this answer, use one line for each set that can be considered a function using X as domain and Y as codomain. For example, this is definitely not the right answer, but that's the format that I'm expecting. Okay, so, well, do you guys want me to write a program to do this, or do you want to just kind of, do it organically, like just manually? Write a program to do it? Okay, so it's good to write a program to do it because in order to write a program to do it, you have to think about how do I write a program to do it? What is the pattern, right? So do you guys have any questions? Okay, all right. So you have to think about what makes a function a function? How do I write a program to generate just sets of functions? So there are two things. One, it has to be a subset of the Cartesian product. That's an easy one, okay? Because you're generating the elements, so you can always restrict the elements or the two tuples to a certain type. So that's not a big concern. The second concern is every element in the domain has to map to one and only one element in the codomain, but it doesn't say which one. So that means you have some degree of freedom right there, which also means that's a place where you can use a loop. Okay, So to write the code, to write the program to do this, okay, let me go to a command prompt and, oh, okay, come on, move, move. There we go. Yep. Well, okay, there are also a few ways to look at this. So let me take a look. Let me switch to the tablet. And I switch my tablet. So I'm using SuperNote today instead of my other tablet. I like this one better because it's lighter and it's cordless, which means I can be cool like writing here when I'm walking around. Okay, it's good to have wireless mic and also a wireless tablet. So the way you look at this is say, okay, so I want to look at element A in X and I want to find out all the options. What can it possibly map to? So now we're looking at the tree. Okay, so it can map to one of the three possible things in the codomain. Namely, A can map to 1, A can map to 2, A can map to 3. Does that make sense? Okay, so now that A is settled, now we say, okay, what about B? Okay, so now we start to worry about B. Well, same thing, right? B can map to 1, B can map to 2, B can also map to 3. So now we have B1, B2, and then B3, like so. So this is where, things can get a little bit uh, handy when I'm using an electronic device because I can now use a lasso tool, select the portion I want to copy. Okay, that's copy. Okay, and then I can use the paste icon. Where's the paste icon? There we go. And then I can put this right here. Does that make sense? Okay, so now I can do the same thing again. Okay, copy and paste. Okay, and then just stash it over here. So now we have covered A, B, right? So while A is mapping to 1, B can map to 1, 2, or 3. While A maps to 2, B can map to A, B, 1, 2, or 3, and so on. So do you guys want me to, kind of draw out, C as well, or do you think you get the pattern? You got the pattern? Okay, all right. Okay, so working this out by hand first is actually important because now that I have worked this out by hand, I notice a pattern. I notice that there's a there are things I can do in the loop. Okay, every time I copy and paste, it is a clue of telling me, oh, I can use a loop to do this. Okay, so that means, oh, okay, so the first loop, the outermost loop is just going to be concerned about how A is going to be mapped. The nested loop in between, the second, okay, the second nested loop is going to be responsible for B, and then the another loop is going to be responsible for C, and they're going to be nested within each other. Okay, is that making any sense? Okay, all right. Yes. There are many ways to do it, so I'm just going to do it in a uh in I'll do it in C, regular C, not even C++, no object-oriented programming here. So this is entirely procedural, okay, which means the program is not very well formatted, it's not supposed to be reusable and so on and so forth, but it gets the job done, okay? I just want to get a quick and dirty way to get the job done, okay? So we're gonna look at the program, and which question is this? This is question number 3, if I remember right. Yep. Okay. So I'm just going to call this Q3 int main. And I have the second element that is going to be a variable. So I can, oh, okay. Doing it in C is not quite as handy as C++ because C++ allows you to declare a variable inside of for, okay? With the C, you cannot do that, but it's not too big of a deal. Huh? Huh? I don't need any array. Look at this. This is going to be so quick and dirty. it will make Ryan and Iraj cringe. They go like, "Ew, where did you learn to program like this?" From TAC, obviously. Okay, so we'll go like int. Yeah, int will work. Okay, so int we're gonna say a2 b2 and then c2. Okay, what they are mapped to. Okay, that's basically what these variables are for. So now we say a can map to I think we start with 1. Okay, and as long as a2 is less than 4, we're good, or less than or equal to 3. Okay, either way it's fine. A2 plus plus, and then we open brace, close brace. Okay, copy, paste, nested one level, change all of these to B. Now, obviously, everything I copy and paste, it also means, oh, I could have probably used a loop to do this, but remember I said quick and dirty. Yes. Okay. There you go. So this is for C. Basically, I'm controlling what C is mapped to in this case. So now we are at the most nested level, and I'm just going to do the really dirty way of doing this. Okay, we'll basically specify open brace, um, A maps to some kind of integer, B maps to some kind of integer, and then C maps to some kind of integer with a line feed, and then we specify A2, B2, C2, and I believe that would get it done. I just need to pound include standard io.h because that's where printf is coming from. Yes, you cannot get it done in 2 loops because every element in X can map to any element in the codomain. I don't think it can generate all 27 cases. Hmm. So you're keeping track of your own stack. Anyway, this will work though. Okay. So are there any questions about this program other than what printf is doing? Because I don't think many of you have learned how to use printf. How many people learned how to use printf in your CISP 360? Nobody. Yes, you did. Percent %D. So percent %D is a placeholder. So printf is how we format output before C in and C out, were more commonly used in C++. But if you write a program in straight C, not C++, this is the only way you can, or this is the easiest way you can format an output. So everything that is just kind of in purple color, it is verbatim. So the brace, parentheses, A, B, and C, the commas, they're all verbatim. Percent %D means this is a placeholder for a signed integer that is supposed to be printed in decimal. That's what the D is representing. It's printed in decimal. And we can see that A2, B2, C2, they're all just regular integers. So the types are matching here. So that's how we use formatted string. And I save the program, gcc-g-o q3 q3.c. Okay, wow, it compiled the first time. And there we go. And to copy and paste this into the browser, this is a Linux thing, okay? If you're envious of this, learn how to use Linux. Hmm? But I can do it on the command line. Oh, it copies to the clipboard. PB copy does it copy to the clipboard. Xclip is kind of the most um, closest way to work with X Windows to copy something to the clipboard. Yep. Absolutely. The code is right here. So the way this works is it's a triple loop, okay, but nested. The outermost loop goes through 1 to 3 for A. The middle loop goes through A to 3, 1 to 3 for B. And then the last loop, the innermost loop, goes through 1 to 3, but for C. And then the only action I need to perform is to go like, what have you chosen for A? What have you chosen for B? And what you have chosen for C? Respectively, they are specified by the variables A2, B2, Z2. Yes. Mhm. Which is kind of a hassle. Okay, so I can rewrite this in a recursive way, so that way you can basically give me any number of elements in X and any number of elements in Y, and it will still be able to do it. But it's slightly more involved, and I don't like to do that in C++. So if I were to go for the recursive version, I would use JavaScript, because JavaScript is just a whole lot easier to do concatenation with strings and stuff like that. But mhm. Yeah, you can still do it in the recursive route, but doing the recursive one in C++ is a little bit more trouble than I would like to go through. So JavaScript would be the one that I would use if I want to do this recursively. Mhm. All right. Any questions about this code? Remember, I did say quick and dirty. So this is kind of as quick and dirty as I can get. Are we good with this? Okay. So now the question is, how many lines did I generate? If you just look at this algorithm here, can you tell me how many printfs it's going to generate here? Exactly. 3 to the power of 3, which is 27. So there are 27 functions that we can generate based on X having 3 elements and Y also having 3 elements. Yep. Looking at the cardinality of X and Y. Yes. Yep. That is correct. Yep. All right. Any other questions about this? Yep. This is not recursive at all. But there is, if you want to, does anyone want me to look at a recursive version of this? All right. You guys really want to? Okay, cool. All right. So we can do it that way. So we'll make this a uh, Node.js. Okay, so it's a different highlighting thing, because I turn on certain options for JavaScript. All right. So now I have to think about how to do this. Okay, I can do it this way. So function, um, okay, we just call it function f. So I need two things. I need to know how many things are still remaining in the domain. So this is D for domain. And I need to know what are the things that we can have in the codomain. So C is the codomain. Um, when so we have, since it's recursive, so whenever you write a recursive function, you need to think of one thing first, okay, which is when does the recursion stop? Okay, so in this case the recursion stops when D is empty, when there's nothing for D to handle anymore. So in order for this to work, I also need to know what has been chosen up to this point. So that's going to be some kind of a string that I'm passing to the function. So I need that. So now I can say if D is empty, so that means the length of D is empty. I would do it in one way, otherwise I do it in a different way. So when the length is empty, the string as should contain everything that I need. So in this case, I can just do a console dot log, and we'll just output string itself. But I need to remember that the string itself is probably well, maybe not a string. So I would need m for mapping. Okay, so I would do a m dot Mm, Okay, I need the braces first. Okay, so two backticks to mean whatever is in between is not a literal string. It can contain parts where I use code to specify the content. Yep, go ahead. Hmm? Okay, just let me do my thing. Let me do my thing. So I'm going to do a map dot m dot map, and we are taking each element of m as an array. So we'll just say that's called element, and we'll map it to okay, I need a dollar sign and then braces and close brace. E maps to each one is going to be a tuple, so I need to print the tuple. So that's going to be a nested backtick here, and we have paren. Okay, I can make this a little bit more fancy, but I think this is going to suffice. Or do I want to make it more fancy? Mm, I think this would be fine. The first element, and then the second element, right? So that goes away, and this is the end of that. I now have to match the close braces, so I need one more brace here. Nope. All right, let me read the nesting of everything here. So this back quote ends this quote here, and then after that, I need to close that paren. Okay, that is correct. And then I have close brace over here, and then I need back take. All right, that closes that. I need another back brace here. Okay, there we go. All right. Okay. So now that takes care of what is printing, and now I just need to figure out what if the length is non-empty. So if the length is non-empty, um, I get another person who is awaiting to get in. Mm, yep. Sorry. Uh-huh. Well, I mean, we'll work with that. We'll figure out what is in M, that is we're passing along. All right, so if d dot length is non-empty, then I need to do a splice. Okay, we extract the first one out, and then we pass the rest recursively. Um, okay, so we need to do. Let me see what we need to do here. Oh, okay, that's not quite the whole thing yet because C is not used at all, so I need to go through C at this point. So that means I need to do what? I need to go through every single one of those. Hmm. I'll figure this out, but probably not using class time. So I will make a video. I will make a video of how to get this one up and running. So that is a to do for myself. Yep, yep. The backticks. So backtick in JavaScript. Okay, so this is. I don't want to turn this class into a JavaScript class. Okay, so Node.js can be interactive. So that means I can show you something like this. I can say let x equals to say 5. Okay, so we have a variable that has a value of 5. And then I can now say console.log. So backtick normally behaves the same way as a normal tick, or double quote. So you can say this is a string, and it would just print it out like this is a string. However, you can also use your dollar and then open and close brace to specify what you want to print as an expression. So in this case, I can refer to X over here. So now it has 5 over here. So it's kind of how we can do formatted strings in JavaScript. And there's no telling of how complex this expression can be. So you can embed like really crazy code inside those braces if that turns out to be what you want to do. So whatever the expression is inside the braces is going to replace this placeholder as a part of the output. Yep. Lambda. You mean in the editor? It's just telling me that something is not wrong. Something is not right. Yep. Yep. All right. So I'll work on this, okay, and I'll explain, how the JavaScript code is supposed to work. Yep. Hmm? Is it called string interpolation? Okay. I don't know. I mean, I just know what it does. I don't know the name, the term that refers to it. Okay, you can always ask, right? What is the name of backtick in JavaScript? It's got the grave accent. It is a powerful feature introduced in ES6. Blah 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 blah. I mean, that's how it's supposed to be called. I'm not big on knowing the names of the terms. All right. So anyway, this is how it's generated. Okay. The quick and dirty way is the way that I used earlier. So now we move on to question number 4. Based on how X and Y are defined in the earlier questions, how many subsets of the Cartesian product between X and Y are not functions? Well, so now it is asking you, you need to find out how many subsets can we create out of X times Y. Okay. We already talked about the concept of a power set. The power set of a set is every element in the power set is a subset of whatever set you're taking the power set of. Okay, does everybody understand what I just said? Hmm? Sure. So every element of the power set of X is a subset of X. So that's kind of the quickest version of what I want to express. Okay, so we need to find out the power set, or at least the cardinality of the power set of the Cartesian product between X and Y. So based on our earlier discussion in previous weeks, does anyone remember the cardinality of a set? Yes, that is correct. So it's 2 to the power of the number of elements in the set. So let's take a look here. So let me go back to my tablet, which is actually here. Okay, there we go. All right, so I'm going to start a new page. And the first thing we want to know is the power set usually uses this particular symbol. So we want to look at the power set of A, B, C, Cartesian product with 1, 2, 3. And we are not even that interested in the power set itself. We just want to know the cardinality. But as you said, the cardinality is 2 to the power of the number of elements in the Cartesian product in this case. So now we are looking at the Cartesian product, the cardinality of the Cartesian product. Okay, so can someone tell me what is the cardinality of the Cartesian product? 2 to the power of 9. So that means the cardinality of the Cartesian product is 9. Does that make sense? Okay, we worked that out in, I think, question number 1, right? So that means now we are looking at 2 to the power of 9, which is 512. there are 512 subsets given that uh, there are 512 subsets of the Cartesian product between ABC, which is X, and 1, 2, 3, which is Y. Is that statement understood? Okay. So of the 512, we know that 27 are actual functions. The rest are not functions. So that means now we have to look at 512 minus 27, and that's a 5, that's an 8, that's a 4. So we have 485 that are not functions. So now we go back here and we answer 485. And I believe that's it. So we got correct. This one has to be manually graded. And that's 485. So do we have any questions about how all the answers are derived? Nope. Okay, excellent. Are we ready to move on to, okay. All right, so we're going to move on to continue with our discussion of Olive Knoll. I hope you guys got a chance to read the module. It is not easy reading, okay? I know there's a lot of stuff in it, and we're going to go through some of that, if not all. Okay, so we go back to Olive Knoll and move on to how we define the G function. So are there any questions about, casually how the G function works? In other words, given that we have a two-dimensional space of tiles, how do we assign natural numbers on those tiles? Just generally speaking, just can you do it by hand? Okay, we can do it by hand. And just to be sure, okay, I'm going to switch back to the tablet just so that we kind of go back to that discussion a little bit, okay? So if this is the two-dimensional space, let me just kind of try to chop it into. The best way to do this is to use a spreadsheet, okay? But I'm just gonna do it by hand for now. Yeah, this tablet is actually not bad. At least, the lines are not straight because of my hand. Okay, so the way we assign the numbers is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and I'm gonna do one more row, okay? 15, 16, 17, 18, 19, 20. Okay, there we go, and etc. So now the question is, if I want you to tell me what is the natural number of the coordinate, so this is X and this is Y, okay? And if I want to ask about the cell that is at the X coordinate is 103 and the Y coordinate is, let's say, 65, okay? What is the number? Well, there are a few ways to do it. You can do it the long way, which means you're gonna have a grid that has at least 103 columns and also, at least 103 rows. And then you just fill it in until you get to that particular cell. Then you know what natural number goes to that cell. Who wants to do that? Like right now on the whiteboard. Probably not, okay? So that is not a good way to do it, okay? Not that it doesn't work, it's just not very efficient, okay? So we want to look for a closed form so that we can say, oh, okay, so I'm gonna use a function called g so that it will tell me what the value is supposed to be at the cell that is 103, 103 in terms of the x-axis. And then once we get to the correct column, it's going to be 65 in terms of the row number. Is that okay? What the objective is? I want to find a closed form if such a closed form exists. We good? Okay. So the rest of the module talks about the reasoning. Okay, how do we figure that out? How do we find the closed form? Now, if you type Cantor's mapping function, no, pairing function, this is called Cantor's pairing function, you can find lots of explanation of how that equation is derived. But instead of reading how it is derived, you have enough math background to figure out how to map it, how to derive the actual closed form. So I'm just going to describe the process that I went through to figure that out. Okay, so it all has to do with pattern recognition. Programming is about pattern recognition. This class is also about pattern recognition. In other words, I look at this table here and I say, do I recognize any pattern? Okay, now what does that mean? Well, pattern recognition means can I tell what goes here? You guys go like, oh, of course we know. It's supposed to be 21 because this is 20, so this is supposed to be 21. Yes, okay, that is correct. Okay, so now we say that cell is a 21. But then if I ask you, what about the one to its right-hand side? And it's going to be 28. How do we know it is 28? What is the pattern that you have observed? Mm-hmm. Yep. Yeah, go ahead. That is correct. Okay, it's plus 7 because the diagonal line is going to have 7 elements in it. In other words, this diagonal line is going to be it's going to have 1, 2, 3, 4, 5, 6, 7 things. So that's why when you go on to the next cell, it's 21 plus 7. So okay, which is 28. So there's definitely a pattern here. The difference between these two is 1. The difference between these two is 2. The difference between these two is 3, 4, 5, 6, 7, 8, 9, and so on. So now the question is, okay, that's kind of neat to know. So if I need to find out, what is, all the way, say, over here. So if I want to say, okay, I want to find out what is the integer or the natural number, excuse me, what is the natural number in a cell that is at x comma 0, what would that be? In other words, this is what I'm trying to figure out. Okay, what is the natural number that is supposed to go to x coordinate x, okay, which is just a variable, and then 0 because we are on the first row. Does everybody understand what I'm trying to figure out? I'm not interested in the rest of the cells, okay? Just everything on row 0, okay? So you go like, how do we work this out? Looks like, yeah, go ahead. It's not factorial. It is somewhat related to factorial, but it's not factorial. So now we go like, okay, what is g of 0, 0? Well, we know that's just 0. What is g of 1, 0? We know that's 1. What is row 2, 0? We know that is 0, 1, 2, and then a 3, and so on. So we look at this and go like, well, it looks like we are just adding everything. If I were to try to find out this one, it looks like it's just going to be a summation where I starts from 0 and goes all the way to x. And we are just looking at I as an index variable. Does that make sense to you? Does that seem to correspond to what our observation was? Okay. So you look at this and go like, okay, let's test it first. Okay. Let's test this equation with g of 2, 0. Okay, so if we are testing with g of 2, 0, then x is 2, I goes from 0 to 2, we're adding 0 plus 1 plus 2, which is 3. Okay, that seems to work out. So you can work out a few more concrete cases just to convince yourself that this is not exactly a closed form, but it is an abstraction of how to get to column x of row 0. Is that okay? All right. So now you look at this and go like, well, but tech, this is still not very efficient. This is still a summation. This is still a sigma. So how can we do this quickly? If you have taken algebra, you probably have already encountered the closed form of this thing here. But let's assume that you have not taken algebra and you understand the closed form of this particular sigma expression. So what you do is you derive it. Okay, so everything can be derived. So I explained the derivation of that whole thing. So g of x0 is 0 plus 1 plus 2 plus 3 all the way to x itself, which is now summarized in the sigma notation. So now you go through all the crazy stuff here. This is just asking, is x an odd number or not? If x mod 2 does not equal to 0, x is odd. And if x mod 2 does equal to 0, then it is even. So I have two cases, okay? This is the case when x is an odd number, and this is the case when x is not an odd number. So what is that actually doing? Well, the thing is, I notice that if you add the first number to the last number, it is the same as the second number added to the second last number. And that's how we can kind of pair things. Okay. So that's the that's what I'm using here. Um, and then what I'm also doing here is I use 2 sigma to get to the middle. So the first sigma goes to the first half. The second sigma is from the point right after the first half to the end of the whole thing. And then I combine the two into one single sigma by changing the indexing of I. And then that whole thing just is generalized into X and so on and so forth. And then eventually I get to the conclusion that, oh, it really does not depend on whether X is odd or not. They both boil down to X times X plus 1, the whole thing divided by 2. Yes. How did I come up with a sigma notation? As in, how did I choose to use sigma to mean summation? Or how did I notice that I'm adding a sequence or series of numbers? So are you looking at this one or the other ones? The first one, this one, this one? So the way I come up with this is to notice when you add the first thing to the last one, it is one particular value. When you add the second one to the second to the last one, it is the same number. You mean this one? Because this is just an expression to say what is the index of the first item and what is the index of the end of the first half of the sequence. And this is the beginning of the second half of the sequence, and this is the end of the sequence. So that's how I derive these. So we know that it's about x divided by 2, but then you have to figure out, okay, is it really just x divided by 2? And the answer is not, because if when x is odd, which is what this case is handling, so because we start with 0, so you kind of have to look at, oh, okay, so we are not just dividing x by 2 because x is odd, x divided by 2 is not even an integer. So you have to go like, okay, either we're adding 1 or we're subtracting 1. But we have to subtract 1 because we are handling the first half, and then this is handling the second half. So that's how I kind of refine or tune the expression so that I can end up with an index that ends with the first half and then starting with the second half. So everything starts off with kind of like an intuition. I know it has to do with x divided by 2, but it's not exactly x divided by 2. Then I have to plug in actual numbers, like what if x equals to 5, okay? Then we have 0 plus 5, 1 plus 4, and then 2 plus 3, okay? So then I notice the pattern is like, oh, okay, 2 is 5 minus 1, the whole thing divided by 2. So that's why, so, but that's how I came up with those equations. Yep. I would not use the floor symbol, because that implies that you're going to be dealing with non-integers at some point. And using this method, we don't have to deal with non-integers at all. Yeah, there are no non-integers because the first half here is when x is odd. When x is odd, then x minus 1 is going to be even. Even number divided by 2 is always an integer. When the this case here is the else case, which means x is even. So when x is even, x divided by 2 is an integer. So I don't have a problem with dividing x by 2 for this case. So I have two subcases to handle, which is when x is odd and also when x is even. When x is odd, we have the same number matching the first half and the second half, which is cool. But when x is even, because we started off with 0, then the thing in the middle is not paired. And that's why it is just hanging by itself out here, not belonging to the sigma. Yep. Yep. Mm-hmm. And then the rest of the derivation has to do with the manipulation of, I can tweak the indexing so that, this one is matching the indexing of the second sigma matches the indexing of the first sigma, but then I have to change what I'm adding. So instead of adding just I have to add x minus I instead. So I'm basically tweaking the um, I'm tweaking where I start with the indexing and where I stop with the indexing in order for both of these sigmas to go from 0 to x minus 1, the whole thing divided by 2. And by doing so, this I becomes x minus I, and then the I cancels out the I, which means I'm just adding x. And how many times am I adding x? It'll be x minus 1, the whole thing divided by 2, plus 1. And that's how we end up with this. Yes, go ahead. Okay, let me see if I know which one you're talking about. Are you talking about this one? So this is the end of the index of the first half. So this is just this number plus 1. So it is whatever is next to the end of the first half, which is the beginning of the second half. Hmm? This is the end. So, when you use a sigma notation, you always start with the lower index and you work your ways to the high index. Right. The beginning index is always less than or equal to the end index. Yep. Yep. Hmm? The two dots in the middle, it belongs to the question mark. So what does that mean? Okay, so we are looking at an expression where there's a question mark and a colon in the expression. Yes. Yep, it is a ternary expression, but you're correct. The operator itself is called the ternary operator, which is essentially if then else in a single expression. And you will find that I use it a lot. Mhm. So are there any questions? I'm not going to go through the whole thing, to explain, how the derivation works, but it's fairly step by step, at least in my mind. So you guys can kind of go through this, and if you have any questions, you can always ask. Yes. Well, okay, so the question is it important to know how this is derived? So there are several answers. It depends, okay? That's my favorite answer to any question is it depends. And most people hate that because it's like, just tell me the answer. There's no single answer. It depends, okay? So it depends. From the perspective of, will I ask you to derive something like this in the exam of this class? The answer is no. So from that perspective, it is not important. From the perspective of, can I at least follow the logic of this thing here? It is kind of important, okay, because I think it is a good practice of your mathematical derivation skills. And I think that is going to be important, okay. And I forgot to mention one of the articles that I was reading over the weekend, but I'll get back to that one. So does that kind of answer your question? Okay, so I think in the long run, it is good that if you can find the time to look at the derivation and understand step by step how one step follows the previous one, it's going to be good. Yep. Right. So you can use the g function as it is already defined. Yep. I do not know yet, but you can assume the answer is maybe. Yes. So this class, I just because of my own personality type, it's it has a lot of variability to how things can be organized. But the bottom line is you have to understand what this is all about. And in any exam, you want your notes to be self-sufficient. Okay, so you don't want to make the assumption that, oh, tech is going to provide this. Okay, but what if tech does not provide that? Okay, so you need to come up with your own study guide. Okay, I don't give people a study guide because your study guide may not work for the next person. Okay, so the study guide is something that you should have been working on since week one. Okay, so every class, after class, you go through the material that we talked about, and then you go like, okay, what is important? Now, I can tell you what is going to be important. Notations, definitions, okay? Those are all important. And you typically want to make sure that either you remember where I put all of those definitions and notations and explanation of the notations, or you copy and paste it into your piece of paper so that you know for sure exactly where you stash it. So you can choose one or the other. I would recommend the second option, which means you are copying and pasting manually all that content, because when you're doing that copying and pasting, you're already studying. That's one of the steps of studying, is to go through the material and make sure you don't miss anything. All right. So anyway, bottom line is, oh, okay. So the whole thing just simplifies to x times x plus 1, the whole thing divided by 2. And obviously, you need to test it on a few cases to see whether it works or not. So if I were to switch back to the tablet, okay, so we're going to take a look at the actual picture, okay, this one here. So we want to test it to see whether it works or not. So we are looking at x being 0, 1, 2, 3, 4, 5. Let's test it when it is 6, okay? In other words, I'm testing to see whether 21 is actually 6 times 7, the whole thing divided by 2. Okay, 6 times 7 is 42. 42 divided by 2 is indeed 21. The next one up this is 7, right? So we are looking at 7 times 7 plus 1, which is 8. 7 times 8 is 56. 56 divided by 2 is indeed 29. Okay, so it's always good to kind of plug in the values a little bit just to see how it works. Yep. Say again? 2 to 5. Oh, that's just poor penmanship on my part. This is 2, this is 3, that's 4. The 0th column. Oh, that we have talked about already, like last week. Yep. It will be pretty easy to do it now, right? Because so let's just say that we want to figure out something that's already in this picture. Let's say we want to figure out uh, this one here, okay? So now you say, okay, where is the base of this diagonal line? Okay, so the diagonal, okay, let me use a mouse pointer because people who are online will not know what I'm talking about. So I have to look at this one. Okay, so we are focusing on this one here. So now you ask, okay, which diagonal line does it belong to? So all you have to do is to project a diagonal line all the way, go like dum, 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 back to the 28. Now you ask, in order to get from the 28 to where the mouse cursor is, how many steps of y do I have to increment? You go like 1, 2, 3. So 28 plus 3 is the value that goes here. So that means once you figure out what is on the diagonal line, at the base of a diagonal line, everything along the diagonal line is just whatever the y is plus the natural number at the base of the diagonal line. Is that okay? Yep. Plus y, not x, because y in this case is 0, 1, 2, 3. So plus 3 is what we need. So this particular cell has a value of 31. Now let's see whether it works or not. So my speculation is I need to look at my speculation is this is supposed to be 31. So this is 30, this is 29, and it works. Yep. Yep. That's it. That's how we, well, okay, no, it's x plus y plus x plus y plus 1, that whole thing divided by 2. Because x plus y tells you which diagonal line we are working with. Okay, so let's number the diagonal lines. Okay, let's number this one. Okay, so in other words, if I'm looking at this particular diagonal line, what is the diagonal line? This is everything adds up to 7 on this diagonal line, because with the diagonal line that I just marked, the first cell at the base is 7, 0. The second one is 6, 1. The third one is 5, 2. And then the third one, which is the one that we just computed the natural number for, is 4, 3. Do you notice a pattern? When you add up the x and the y of the coordinate of all the cells on a single diagonal line, they all add up to a specific value, which turns out to be the x coordinate at the base of the diagonal line. Is that making any sense? Okay. So that's how the whole thing is derived. Okay, so the derivation of the final form of the g function is this. Okay, it's x plus y. I misspoke a little bit earlier. It's x plus y times x plus y plus 1, because x plus y itself identifies the base of the diagonal line. Okay, so without the plus y over here, we're computing the natural number that goes to the base of that diagonal line. But by adding y, we are now computing the actual value of the cell that we're interested in that is not at the base, or not always at the base. Is that okay? So I think the important part about all this thing here is how I derived the thing, how I derived the final closed form of the g function, which is also once again known as Cantor's pairing function. The significance is just that. All right. So I'm gonna take roll at this point, and I'm gonna have to remind people this is an in-person class. So online access, through Zoom is only on a per agreement kind of, arrangement. So people without, the pre-arrangement ahead of time will be marked as absent in this class. And I'm gonna take roll, and I'm just gonna modify this one to reflect today's date. This is 0219. And obviously I have to change a few other things. So dragon, I can keep that. And I'll change one more thing. Over here. And the time, I'll give you guys until 1:30 p.m. to do it. That's plenty of time, I hope. And the date is today. And then save and publish. There we go. So you should be able to get into the role taking activity. The word is dragon. I cannot even remember why I chose the word dragon last time. Yep. It means you have to be on campus. Yes. Huh? What do you mean by unmap? Oh, nmap. I do not know. This is not a single address. This is a network address, right? So I specify a range of IP addresses. Hmm? I think this one is dash 16 because of the way the district sets up the network. So from the outside, every internet access from the outside is going to map to one of these addresses. So inside the network is 1030 for wired and 1036 for wireless. But once you get outside, all of those map to 165, 196 something. All right. Uh-huh. Are you using your cell phone instead of the school network? Yeah, you have to use the school Wi-Fi, or you can send me an email. Yeah. So we learned something about networking today too. But let me go find the article that I wanted to talk about. Um, the article was about Greek logic. It had to do with Amazon, AWS, and AI. Yep. Yep. So this article is interesting from our perspective because we are going to talk about propositional logic, which I think is what they're referring to as ancient logic. Is basically the Greek came up with they're the first people who came up with the formal treatment of arguments using logic, and that's what we're going to be talking about in this class. So, most of the time, in this class, most people think this class is really just a checkbox on your degree. Um, but I don't think that is the case anymore. Okay, the fundamentals are actually becoming more important in the face of AI. Um, so it's kind of interesting, I think. So if you guys want to read the article, I can send a link to you, but you can just search for it too. So the search that I did was simply to look for Greek, logic, Amazon, AWS, and AI. All right. Yep. Hmm. Or double check whether you're hallucinating or not. But the more insightful question is to ask, figure out why you're hallucinating to begin with, so they can prevent it from happening in the future. You can actually ask AI about those questions. It can be a little bit on the self-reflecting side, even with the AI with ChatGPT. So if you have not done that before, you can try it out. So it is scary that OpenAI is also trying to court the Pentagon to get defense contracts. All of them are okay. If you look up, um, I think it's Project Stargate, $500 billion. Okay, so look it up. Okay, look this up. Okay, Stargate project, announcing the Stargate project, and you can see this is from OpenAI itself. The Stargate project is a new company that intends to invest $500 billion over the next 4 years, building new AI infrastructure um, for the United States, but it's actually kind of leaning to the military side. We'll begin deploying $100 billion immediately. This infrastructure secure American leadership in AI, blah, 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 blah. So if you do not know what this one is about, you might want to read about it. Yes, go ahead and then you. Go ahead. Hmm? Exactly, because they are also in the same sentence trying to reduce the tax burden of the billionaires. So who's going to pick up the bill? Yes, go ahead. Hmm? Skynet? I don't know. I mean, I don't know whether it will get to that point or not. But if you look at the players, okay, we got ARM, okay, which owns the IP of all the chips in your cell phone and your portables. And by the way, ARM is also moving to start to manufacture their own chips. So they're going into fabrication as well. So we got Microsoft, the typical player, Oracle, typical player. We have NVIDIA making all the chips, for the AI application, and then we have OpenAI, basically doing the uh, trained AI stuff. So we got all the big players, to try each one trying to get a cut of the action, basically of the $500 billion thing. Yep, I don't know what's going to do. I don't know what it's going to do. So anyway, so we now get back to the inverse function, okay? Because is that Cantor's pairing function, is it bijective? Okay, we talked about that last time, right? So let me go back to the tablet. So let me ask you this question. Is it injective? What does it mean in this case to be injective? Every element in the domain, which is the two-dimensional space, maps to one and only one unique value in the codomain. The codomain is just a set of all the natural numbers. So if you follow this way of you filling in all the cells, do we guarantee that every tile maps to a different natural number? Intuitively, yes. Okay. All right. So we also need it to be surjective. In other words, do we use up all natural number? If I just give you some random, huge, gigantic natural number, do you think it belongs to a particular cell in this two-dimensional space? It's just a matter of how long does it take you to get to that particular cell. But yes, we are guaranteed that all natural numbers will be mapped to. Okay, cool. So now it is injective and surjective, which means it is bijective. But because it's a bijection, we also know that has to be an inverse function, which means if I give you a natural number, you should be able to find out which cell in terms of the XY coordinate has that natural number. Does that make sense? Yes. Say that one more time. I don't know what the answer to that question, because I think what you're asking is aleph one instead of aleph null or aleph zero. So I believe that may or may not be an equivalent definition of what we are dealing with here. So, but I cannot answer that question. I don't know whether there can be a bijection between, sets that are uncountably infinite, because the sets that we are dealing with here are countably infinite. All right. So knowing that there's a inverse function, I don't know about you, but I'm curious about what that inverse function should look like. Okay. And the rest of this module is about the derivation of the inverse function. Okay. So when you look at the inverse function, you're also going to have to figure out patterns. In other words, if I just give you one gigantic number, can what is the clue to get to that one, to get to that particular cell? So one thing we know is g of w0, w being just any natural number, is going to be this, okay? Because anything on row 0 is going to look like this in terms of the g value, because it has no y component to it. And n is the natural number that I give you. So the first thing I need to do is to figure out how far do I have to push the diagonal line until I get to the diagonal line where that natural number is going to be on. Is that okay? So that's what I want to push. I want to push for the largest W such that w times w plus 1, the whole thing divided by 2, is less than or equal to n. Because if I can find this w, the largest w that satisfies this requirement, I would have found the base of the diagonal line. Once I find the base of the diagonal line, it will be pretty easy to find out, exactly which pixel on that line the number n belongs to. Yes. N, okay, n is the natural number that we want to figure out where it is in the two-dimensional space. So that means the cell containing n is not always, or most of the time, is not on row 0. It's on some row, okay? But it will help me tremendously just to figure out which diagonal line it belongs to, okay? So I set up an inequality, okay? This is an inequality. So with an inequality, you can still do most of the algebra that you normally do with just equality. So that means, what that means is I can still go through the same derivation, move all the terms to one side of the inequality so that I have 0 on one side, and then the other side looks like a quadratic, not equation, is a quadratic inequation, okay? Or, because it's less than or equal to instead of equal to. But I can still use a quadratic equation to find the roots. So this is just a quadratic equation with all the coefficients plugged in. So A is 1, B is 1, C is -2. Plug it into the quadratic equation solver. Now, the quadratic equation solver is going to give me one number that is negative, because you can see this is -1 plus or minus blah, blah, blah. So I can ignore the negative side because, each cell, the coordinate of each cell can only be a tuple of two natural numbers. It cannot go negative. So that means, okay, forget about the negative. We only care about the positive or the plus here. So using that, basically I change this equation into something like this, and W can be seen as the floor of whatever this solution is, because I need that W to be as large as it can be. Is that making any sense so far? Yes? Okay. So now if I can solve for W, this means I can solve for W. Once I can solve for W, I can then solve for Y, because W is X plus Y. Okay, so this X plus Y is W, this X plus Y is W. So this constant here is something that we can easily compute. So we can now say N equals to this thing plus Y. N is given, W is solved. So now we can move everything on one side, Y is on the other side. This is how we can solve for Y. Once we solve for Y, we know that we know W is X plus Y. We know what W is because of this part here. We know what Y is because of this part here. So once we have W minus Y, we get X. So that's how we can solve for X and Y given N, which is the natural number that appears on a particular tile in the two-dimensional space. Is that okay? All right. So it's not important, okay? But I want to point out that, I derived this whole thing by myself, because, the point is I cannot teach something just out of a book, okay? I need to understand how it works. Now, to me, the closed form is useful, obviously. So if I define W of n to be just this thing here, then I can define, X of n to be this, Y of n to be this. And now we can now, basically go backwards. This is the inverse function of G, which maps a single natural number back into a two-dimensional coordinate. Is that okay? All right. But going through the process of reasoning out, how to do this is an important exercise. Okay, since you're supposed to spend 2 hours per hour of lecture, that's one thing that you can do. Okay, is to kind of at least follow the logic and to figure out, okay, how do we go from here to here, and what clue did I use, in order to come up with an idea of how to solve it. Is that okay so far? So learning the knowledge of any class obviously is important. Okay, but that's a very short-term thing because I can guarantee you any programming language that you learn here and also at a 4-year university is obsolete before you graduate with your bachelor's degree. So it's not the knowledge that is important. Okay, it is the principle and the fundamentals that are important. So every time your professor, not just me, but all the professors that you will encounter in your future, every time your professor mentions something about reasoning, it's good to find out how the professor reasons that out himself or herself. Learning how your mentors think is important, not just what they know, but how they learn and how they reason. I think that is much more important than learning what they know. But that's just me. Okay, people can certainly disagree. It also depends on which professor we are talking about. And then there are some AI generated questions, and the prompt is right here. So for those of you who are interested, you can click on this and go to ChatGPT and find out how I made that prompt. So that's a little conversation with ChatGPT that I had in order to come up with the questions that was in that particular thing. Do we have any questions about Aleph? No. Okay, I can give you a preview of what we'll be talking about next week. The first thing we'll do on Monday is to go over exam one, and a copy of exam one from last semester is already attached to the announcement. So my recommendation is to use this long 5-day period to try to answer those questions as much as you can, and possibly without asking other people or asking AI, just try to push yourself as far as you can go. And we'll talk about it on Monday, okay? Because, and the way to work on this, okay, and I can tell you that this is, okay, you can click on it and find out what it looks like, okay? So we'll go ahead and kind of check it out a little bit here. All right. Nope, these are generated by my script. And yeah, well, there are occasions where I did, generate errors. So the question, you can see that, it is all in mathematical notation, which means the first thing you need to know are the notations. Okay, how do we use the notations? How do we read and interpret the notations? The definitions, notations, start with those. And as you study, okay, you can also use that opportunity to create your study guide, which you can also take to the exam itself. So basically, you are doing multiple things at the same time, okay, by going through the exam from last semester. Um, so we'll talk about these, next Monday, on Monday, and then your actual exam is going to be 1 week after next Monday. So that way, next Wednesday, you guys have a chance to ask questions in class based on the exam questions that I show here. So that will give you quite a bit of time to study, prepare, ask questions about it, and so on. Okay, but just knowing that this is going to be open book and open notes, it's going to be helpful. Okay, because this gives you more than a week, quite a bit more than a week. Okay, it's basically 2 weeks minus 2 days to create your notes that you will bring to the exam. Okay, you can work together. By the way, okay, I think it's a good idea to work together so that you guys can kind of what? Sorry. Well, you can do that too, but in that case, I'll give people a 0 and a reference to the student discipline office. In terms of can and cannot, yes, you can. There's just a consequence attached to the action, like everything else in life. Hmm? So the curve is I look at the fifth highest score of the class, and then you look at it as the new 100% and just rescale the entire class. Hmm? Well, I look at the reason, whether it's a reasonable number or not. If it is not reasonable, I reserve the right to change, where the percentile is. All right. So let me stop the recorder first, and then we go ahead and ask the question. All right. So I'm going to stop the recorder and also Zoom.